you draw a vertical asymptote. So I know that's a new idea for a lot of you guys. I'm drawing a vertical line at 2 and negative 2. And these vertical asymptotes are places where my rational expression has 0 on the bottom. That means they're places where the function can't exist, because you've been told time and time again you can't have 0 on the bottom. So the function can't exist, but it is going to sort of snuggle up to these things. We'll talk about why that is a little more tomorrow. The other thing I know about this is it has an x-intercept at negative 5. And I know it has a y-intercept at negative 5/4, which is negative 1 1/4, which is about there. Okay, now from here, I want you guys to be able to identify all these things by hand, but then possibly use a calculator to fill in the rest. Well, for today, I want you to use a calculator to fill in the rest, but I'm going to start showing you guys how to fill in all of this by hand, probably tomorrow. What does a calculator show this thing looking like?
Really weird.
Really weird. Here's what your calculator does. Okay? I'll put this in front of the camera for a moment. How's it doing there?
Okay.
Okay. Your calculator is actually going to draw the vertical asymptotes, which is really annoying. And yeah, it draws the vertical asymptotes on here, and sometimes it makes it look like it's touching them before it actually is. Okay? But those vertical asymptotes are not part of the graph, and I always draw them dashed. You should always draw them dashed yourself, not solid. Okay? But your calculator will do most of it. Your calculator has this thing looking something like that, and then I need to see one part of it again. Okay, I'm graphing this again with a little more range because I want to check something. Maybe your calculator's dying on me.
It is?
Well, it's taking a long time to think anyway.
Oh.
Let's try that again. Okay, there it goes. Yeah, okay. So it goes like that, and then it keeps going. That part's weird. From here, I think it does something like that, but you don't need to worry about that for now. Okay, here's what this function does. It's not allowed to exist here and here.
It looks like a bridge.
It does look like a bridge. It looks like a Golden Gate Bridge or something. Some of them will. Some of them will look very different. There's a couple things you can do to start guessing what this will look like. First, I'll do the bottom like this. Let's see if I can start touching on some of these ideas. Okay. When x gets really, really big, what's going to happen to this fraction? What do you think will happen to this fraction when x gets really big? It'll work. What do you think will happen to the size of this fraction? Will it get bigger? Will it get smaller? What happens if you put huge numbers in for x?
It's smaller.
The whole fraction gets smaller. I've got x on top. The plus 5 and the minus 4 will stop mattering. Like if I put 10,000 in, the plus 5 and the minus 4 won't matter. This is going to be x, a large number, over that number squared. That's going to start making for tiny fractions. It'll just get tinier. So that means that this function is going to keep getting closer and closer to 0 without touching it. So this function also has a horizontal asymptote here. Okay? You can also plug in numbers and check some things. We'll talk about this. It's going to, okay. When x gets really large, will this ever be negative? When x gets really large, is it possible for this to be negative? No, because I'll have a positive number plus 5 over a huge number minus 4. Yes, it'll always be positive. It'll never be 0. It'll keep getting closer and closer. So that's how I know that this function keeps snuggling up to the x-axis. And I'll explain this in more detail later, but for now, just trust me. It also snuggles up to a vertical asymptote. So I know it has to look something like this because it's always positive over here. I know it can't go below I know it can't cross the x-axis because to do that, it would have to be 0 or negative, and that won't happen. if I plug in numbers between 2 and negative 2, I will always get a negative number in here. We'll talk about why that is. But that's how I know this thing has to always be negative in here. This side's a little bit trickier. So for now, the big thing is finding, for tonight's homework, the big thing is finding asymptotes and getting a rough idea of what these things look like. And I want you to play around with that with your calculator mostly. There's also making some tables on it, where you just plug in numbers. Who's really good with the trace button? All right with it? Okay. There's some tables in here. A lot of you guys like to use the table function on your calculator for this. I don't like the table function for this as much. Did you plug it in here, Matt?
I have it on there.
All right. Let me see what I said. What you want to do for these tables of values that your homework gives you is you want to bring up the graph, hit the trace button. Okay, when you're making these tables, you want to put in, when you're in trace mode, you can always enter and hit an X value and hit enter, and it'll give you the Y value. Okay? So you don't want to go to your table function because this thing asks you for some decimals. So if I just want to check points, like if I want to make sure, really, is this all negative in here? I can just go 0, enter. Y is negative 5/4. 1, enter. Y is negative 2. Negative 1, enter. Y is negative 4/3. This will tell me that. The trace button is the fastest way to do it, and you don't have to use these little arrows to go side to side. Actually, when you're in trace mode, just hit a button, hit a number, hit enter, it'll put in the X, it'll give you the Y. Does that make sense? More practice. Bring these tomorrow. I think you'll need them for this. Sam, I know you want to keep up with honors precalculus. I'm going next week. I'm going to make them do a lot of this without a calculator. So you might want to practice some of that or pay extra attention during those parts. Okay. Other than that, find the zeros. Oh, domain. What does domain mean?
Like something to do with numbers.
Something to do with numbers. You're in a math class, Dean, so it's
a good definition.
It's a good definition of anything we run into. Dean, have we discussed the difference between accuracy and precision? Your answer is very accurate.